Hi everyone, welcome to the video on single phase full converter fed DC drive. In this video, we are going to study the single phase full converter drive used for controlling separately excited DC motor. Here we will understand the power circuit, the operating principle of this power circuit, continuous armature current operation, voltage and current waveforms, and finally, the power flowing during motoring and regenerative braking. Now, look at the power circuit. The AC supply is connected to a single phase, fully controlled bridge converter consisting of four thyristors T1, T2, T3, and T4. The converter feeds the armature of a separately excited DC motor. Notice that the field winding is supplied from a separate DC source. Therefore, only armature voltage control is controlled using this converter. The armature circuit consists of armature resistance, armature inductance, LA, and the back EMF EB. Because of the armature inductance, the armature current remains almost continuous. Now observe the quadrant diagram. The horizontal axis represents the armature current. The vertical axis represents the armature voltage. Here, the armature current always remains positive. Armature current remains always positive. Its direction never changes. However, the armature voltage can be either positive or negative depending upon the firing angle. Therefore, the converter operates in first quadrant and fourth quadrant. That is why this drive is called as two quadrant converter drive. A full converter is a two quadrant converter, can produce both positive and negative average output voltage, keeps the armature current unidirectional, is mainly used in separately excited DC motor, and it is suitable for medium power and medium power applications. The motor is supplied, so motor field is supplied independently. Now let us look into the continuous conduction mode. Because the armature inductance is sufficiently large, the current never becomes zero. The current never becomes zero here. Hence, a continuous current flows in the armature through to the motor. This is called continuous armature current operation. Now let us look into the firing sequence. First, thyristor T1 and T3 are triggered together at firing angle alpha. After 180 degrees, T2 and T4 are triggered at pi plus alpha. After another half cycle, again T1 and T3 are fired. This sequence repeats continuously. Since the incoming thyristors naturally take over the current, commutation is called natural commutation or line commutation. Now let us understand each and every one of these waveforms. The first waveform represents the AC supply voltage. It is simply a sinusoidal waveform. The second waveform represents the armature current. Since the armature inductance is very large, the current is always continuous. Now, the third waveform represents the armature voltage. For firing angle from alpha to pi, the converter applies positive voltage to the motor. After pi, the voltage becomes negative. Therefore, by changing the firing angle, we can control the average armature voltage. The current remains almost constant. It never becomes zero. This confirms continuous conduction mode. Now look at the current through the thyristors T1 and T3. These thyristors conduct only during the firing interval. During the next cycle, T2 and T4 conducts. Thus, each thyristor conducts alternatively for approximately 180 degrees. Therefore, the conduction angle gamma is equal to 180 degrees. Finally, the source current. Observe the source current waveform. The source current follows the converter conduction pattern. It changes direction according to the thyristor conduction pair. Power flow. Now let us understand how the power flows. Energy flows from the supply to the motor during the period alpha to pi. The converter supplies positive voltage. Current is positive. Therefore, energy flows from the AC source to the DC motor. This is called motoring operation. This happens between alpha to pi. Between pi to pi plus alpha, the armature current still remains positive, but the converter voltage becomes negative. Hence, the motor returns energy back to the supply. This is called regenerative braking. That is between pi to pi plus alpha, between pi to pi plus alpha during this region. The motor acts as a generator and stored the mechanical energy is converted back into electrical energy and fed back to the AC source. This improves the overall efficiency of the drive. Notice that the conduction angle is represented by gamma and is equal to 180 degree. This means that once a thyristor pair starts conducting, it continues until the next pair is fired. This is the characteristics of the continuous current operation. The major advantage of the full converter drive is that provides smooth armature voltage control, accurate speed control, and the capability of regenerative braking, making it highly suitable for separately excited DC motors. And this is what all about the continuous current operation of a single phase full converter fed separately excited DC motor. Thank you for your patience listening. Thank you.